Hey everybody, thanks for joining us on the Vonage Developer channel. We've got a guest today to talk about the Vonage Python SDK and specifically about the Pydantic library that the SDK employs. Hey Karl, welcome to the channel. Before we get to the meat of it, can you give people a sense of just kind of who you are and what your role is at Vonage?
Jeremy, sure. So I'm part of the developer experience engineering team. So one of our primary responsibilities is building and maintaining the Vonage server SDKs. So when a developer wants to use a Vonage API from Python, Node, PHP, Ruby, whatever language they're working in, our team is responsible for making that a good experience.
Huh, cool. And maintaining is almost underselling it. You're not just keeping the lights on, right?
Right, well, so we're actually actively shipping new features. When a new capability lands in the Messages API or the Voice API, for example, it's on us to expose it in every SDK, which means as an overall team, we're regularly touching code bases in 6 different languages at the same time.
Wow, 6 different languages at the same time. What's your honest take on that? What's really great about maintaining 6 different languages? And I'm sure there are hard parts. What are the hard parts?
So the great part is that you develop this kind of broad intuition for how different languages approach the same problem. So most high-level programming languages broadly share the same set of concepts like variable scoping, inheritance, so on. But there are specific differences in each language and the way it implements those things, right? Either for historical reasons or because the language's whole philosophy. So that cross-language perspective is genuinely invaluable, in my opinion, and gives you a much deeper understanding of core programming concepts at an abstract level, rather than just knowing how they work in a language specific way.
Yeah, I think that's underrated actually, working across languages. I think it makes you better even at your primary language because it gives you kind of a conceptual understanding and you start to see patterns that otherwise you wouldn't see. Maybe a bit like spoken languages and how if you learn a second language, you learn a lot about your first.
Yeah, exactly. I think once you realize, for example, TypeScript's type system and Python's type hints are essentially solving the same fundamental problem. You stop being confused when you switch. You start thinking at a higher level than just the syntax.
Ah, boy, that sounds valuable. Um, so what about the hard part?
Yeah, of course. So there are definitely hard parts of this. So occasionally you're having to get out of your comfort zone, for example. My background is mainly Ruby and JavaScript. I'm comfortable with Python. I have some very old experience with PHP, but something like Java takes a very different approach in some fundamental ways to those languages. Like Java forces your brain to operate with completely different idioms to the ones I'm used to. Like Ruby and Python want you to think one way, Java wants you to think a different way. So, like when I'm reviewing a PR or a change in the Java SDK, for example, I need to kind of slow down, take a more deliberate approach than I would do with, say, JavaScript.
How do you manage that as a team?
So I think having people who have a depth of knowledge of a specific language helps a lot. I've had some really great conversations during code reviews about why a specific SDK implements things in a particular way, or what's idiomatic for that language.
Okay, so let's talk about Python specifically. You've been spending a lot of time with the Python SDK, I know, lately, right?
Yeah, quite a bit. We've been adding coverage for some newer API features, such as Vonage's Identity Insights API, and some improved RCS implementation in the Messages API.
Is there anything in particular about how the Python SDK is implemented that was a surprise to you?
Yeah, so one of the things that struck me is how central Pydantic is to the SDK as a whole. So it's not just a dependency you can glance past, it's kind of foundational to how everything works within the SDK.
Was that your first real exposure to Pydantic?
First serious exposure, yeah. I was aware of it as a library, but I hadn't really previously had the opportunity to work properly with it. Once I did, though, it's one of those moments where you think, where has this been my whole career?
Okay, let's back up for anyone who hasn't encountered it yet. Can you tell us what exactly is Pydantic?
It's basically Pydantic is a data validation library for Python. The core idea is you define a class that inherits from what's called BaseModel, and you declare your fields with type annotations. And what Pydantic does is it enforces those types at runtime. So the purpose isn't like static type analysis, but rather validating actual data that flows through your program.
So that matters, right? Because Python's type hints are normally just hints.
Yeah, exactly. Python doesn't enforce them by default. You can annotate a field as a string, for example, pass in an integer, and Python will run it just fine. You can use a library like MyPy to perform static type checking based on those annotations, but Pydantic goes beyond that. It says, no, let's actually validate the data. And it does that the moment you construct the object, not somewhere downstream where things can blow up mysteriously.
What happens when validation fails?
So you get a validation error, and this is one of the things I really appreciate about Pydantic. It's not just a generic exception with a vague message.
Hmm.
It gives you a structured breakdown, like which field failed, what value was provided, what's expected, and you can iterate over the errors, serialize them to JSON, forward them to wherever you need.
That sounds huge to me, especially in a library context where the error might surface in someone else's code and you need to know exactly what's going wrong even if you didn't write it.
Validation errors feel like first-class citizens. You can catch them, inspect them, handle them gracefully. It's a completely different experience from a type error that just says expected string got it with no context.
What about when built-in type constraints aren't quite enough for you?
Yeah, so Pydantic gives you some really useful functionality for more complex use cases in the form of field validators and model validators.
Hmm.
So these are functions which implement some sort of custom validation logic. Field validators for individual fields. You can say this string must match a certain pattern, or this number must be positive. These can be applied using annotations or via the field validator decorator, and model validators for cross-field logic with like within an entire model. For example, if field A is set, then field B is also required.
Oh.
And this can be applied using the model validator decorator. These cover the cases where type bits alone can't really express your constraints.
So walk me through how the Vonage Python SDK actually uses this.
Yeah, so in a few distinct ways. First, the payload for every API request is modeled as a Pydantic base model. So instead of building a raw dictionary and passing it to an API call, you construct a typed object. Pydantic validates it before anything leaves the client.
Ah, so that means that you can catch mistakes on your dev machine and not in a 400 response from the server, right?
Exactly, that's the whole point of it, really. The error is like immediate and specific at the point where the object is instantiated. So even before an HTTP request is made. On the response side, the JSON we get back from Vonage's API is deserialized and typed in the models too, and instead of a basic Python dictionary. So instead of poking around in a dictionary using its keys, you get a custom object with .access and ID autocomplete.
What about optional fields? Most API request bodies are mostly optional parameters anyway.
Yeah, so Pydantic handles that pretty cleanly. You declare a field as optional with the data type and with a default of none, and Pydantic won't require it. And when you serialize it to send the request, you can exclude the fields that weren't set. So you're not sending a pile of nulls that the API doesn't want.
Okay. Tell me about the model underscore dump pattern that I've seen throughout the SDK.
Yeah, so model dump turns a Pydantic model back into a plain Python dictionary, which you can then serialize to JSON to form your HTTP request body. One interesting feature for us is model dump by alias equals true. So some of the older Vonage APIs use dash case or camelCase for multi-word field names, but the Python convention is to use snake case.
Yep.
Pydantic lets you define a snake case attribute and give it an alias with like a different case, and then use by alias equals true to serialize using the alias. So the Python code stays Pythonic, but the request body the API sees is exactly what it expects.
Wow, that's such a clean solution to a problem that used to require quite a bit of ugly manual mapping, I think.
Yeah, it's one of those things where once you've seen it done right, you can't imagine doing it another way.
Yeah. Are there any other examples in the SDK where you've had to implement some sort of a more complex custom validation, like maybe using the @model validator decorator that we talked about earlier?
It's actually implemented a feature recently where I had to use this approach. So one of the APIs where Pydantic is most heavily used is the messages API.
Mm-hmm.
So this API lets you send messages across multiple different channels, such as SMS, MMS, RCS, WhatsApp, and all. So each of those channels has multiple message types like text, image, video, and so on. As you can imagine, there's a lot of models or combination of models. Yes, that makes me think actually something I haven't mentioned yet is using inheritance with Pydantic. Since Pydantic model is basically just a Python class, you can inherit from other classes and use it as a subclass. This is great for something like the messages API, where the various message types share a lot of common properties, but then have like type-specific properties in addition to those. But yeah, your question was about model validator decorator, so I should probably answer that. The RCS messaging channel has a message type of card. So you send rich card messages containing like text, media, suggestion buttons, and so on. And cards have a number of configuration options, some of which are based on the orientation of the card. So for horizontal cards, for example, the image alignment parameter is mandatory. But for vertical cards, you don't need to set the image alignment parameter, but the media height parameter is mandatory. So being able to implement some conditional validation using the model validator is perfect for a use case like that.
Well, that's really cool information, Karl. I feel like we've probably only scratched the surface. There's probably a whole lot more to Pydantic, but I think that this is going to give people a solid foundation for why Pydantic matters in your library, especially if they're working with the Vonage Python SDK and they want to understand exactly what's actually happening under the hood, right?
Happy to dig into it. The Pydantic docs are genuinely excellent if you want to go deeper. And the Vonage Python SDK is open source, so everything we talked about today is there to look at.
Awesome. Okay, all the links are in the description. Karl, thank you so much for joining us. Really appreciate having you on.
Thanks for having me, Jeremy.
For more information on any of Vonage's APIs and supported programming languages, subscribe to this YouTube channel, join our Slack community, and check out our blog at developer.vonage.com.